lot of you are joining now. That's excellent. Glad you decided to join our call today. Before I introduce you to our presenter for today, I just want to take care of a couple of quick housekeeping items. So first of all, please note we are recording this webinar, and we will make the copy of the recording available to all of you who registered afterwards so that you can review it and have it to refer back to. Also, the other item to note is that we are taking questions during this webinar, and we'll save some time at the end as well, specifically for that. But if at any point in time you have a question, feel free to use either the chat box or the Q&A feature to ask a question. And the panelists will be able to see those questions, and we will try and answer as many of those as we can as we go. So with that, thanks for joining, and I'm going to hand things over to Howard Yu, who's an engineer at Wavefront, and he can introduce himself.
Thank you, Caroline, and good morning, good evening, good afternoon, everybody. My name is Howard Yu. I'm a system engineer working for Wavefront team in VMware, and I'll be happy to do some of the Wavefront by VMware overview, and also show a demo so that you could understand some of the capabilities of Wavefront in general, and also understand what we are trying to do in the modern application observability. So this educational seminar or session will last about close to maybe 40 minutes. At the end of the seminar or session, we're going to have a little bit of a brief Q&A, as you might have some questions going forward. So please revert most of the questions after the presentation and the demo, and we can actually focus more on that later. So I just wanted to kind of start this webinar with introducing the challenges and the characteristics of modern application development. So today's applications are very rapid and also have a lot of things that are quite challenging in terms of the traditional monolithic application development. That the culture is changing as well as the technology. The softwares are not deployed in a standard release cycles anymore. There's a more rapid pace of the software development and deployment that's happening in today's modern applications. We have a continuous integration and continuous delivery pipeline that many of the codes are getting pushed and then getting released without any defined or predefined schedules or predefined set of release cycles. And that's actually pushing a lot of the technologies to incorporate many of the newer platforms like container orchestration, like Kubernetes or the Cloud Foundries. And also development itself is more focused on not having a monolithic application, but having a modularized application, loosely coupled set of microservices that actually constitute to a singular business transaction. So inside these transactions, we have many of the microservices doing their parts, as well as running. They're all running on a very nimble yet very dynamic container architecture, so that we do see those kind of changes affecting how developers deploy and code nowadays. The continuous delivery and the DevOps thus have become mainstream. So not only a small set of developers, but the mainstream developers are actively adopting this new culture of having a development and operations kind of work very closely, tightly coupled together. And we now see a set of like small teams, like small development teams maintaining each individual microservices or each individual piece of the softwares that have their own ops and that responsibilities at the same time. So these kind of very volatile, very dynamic nature of the software development is actually also changing the landscapes of how the development organizations are to be structured and also be run. And because of these kind of changes, it actually gives a lot of opportunities to development, but at the same time gives a lot of challenges. And there are many obviously challenges in this very agile and dynamic nature. And one of the things that we want to focus in this webinar is the lack of unified visibility. That's pretty much affecting and impacting many of the critical services to be pushed in a very fast pace. What I'm actually implying is that without being able to have a full observability of all the things that your development is touching, such as your infrastructure level, your container level, and also your application level, and also business context level, you cannot really push out or make changes to your applications in a much faster pace. The model says, if you cannot see everything, essentially you are not being able to run faster. And if you are not able to run faster, you're not going to be coping up with all the competitions that's out there with this fast change development. So that's one of the things that we kind of notice as some of the challenges of modern application programming, where application development teams have a very limited set of visibilities or being able to monitor in real time of whatever that's happening across all their stacks. So this was actually the motivation of the Wavefront. Wavefront is a SaaS-based, meaning software as a service-based application that delivers high-performance metrics monitoring and analytics platform on top of it, such as alerting and also performing a lot of the ad hoc queries to the users. It helps users to first collect all the metrics from all of their stacks, ranging from their variable metal to virtual machines to cloud, both public, private, or hybrid, doesn't really matter, to the top of the application specific metrics or custom metrics. It's all being collected in a SaaS fashion, so that once it's being collected, it has pretty much a unified UI and API to perform the queries to detect spots and trends or the signal from all your noises, to consolidate all your alerts and detect anomalies in a singular fashion, so that you don't have to go through multiple places or multiple tools to detect those anomalies. And also the visualize the metrics at scale, meaning that even though it's a SaaS product, it is highly scalable. It is guaranteed to perform very well under very heavy load conditions, up to a couple of millions points per second rate, so that you don't really have to make your development team focus on optimizing your monitoring tools, or having to worry about handling storages or sizing up your monitoring tools to cope with your telemetry needs. It is guaranteed to grow as your metrics ingestion grows, and also perform a blazing fast queries without any downsampling of the data, so that you enjoy all those high-end analytics and visualization capabilities without investing too much of your time and effort to make it as good as this. So that's the whole idea of the SaaS-based metrics monitoring, and that's what Wavefront is trying to do. So we essentially provide all the integration points by a form of tiles. So in our web pages, we have over 200 integrations that covers all of these that you're seeing on the left pane, from the business metrics to user specific, transactional application code. So we have a instrumentation library that you can put, you can generate metrics within your code. We also do support very closely with the Kubernetes in a distributed frameworks like container orchestration. We do have integrations from the data store, like databases, message queues, containers, operating system, virtualization layer, or the bare bone devices like network and storage and compute devices. Whatever that is, our aim is to collect the telemetry data that's happening across all your stacks so that you don't have to go around collecting them by yourselves. And once that's being handled inside of Wavefront, and since Wavefront guarantees a high scalability, they are immediately available as you send them to Wavefront. And from that point on, you have a singular, very good, unified way of creating rich dashboards and visualizations, and that can share across all your team members. And also create smart alerts that would work across all the stacks, all the metrics, so that the alerts are not really limited by certain environmental systems. It can run across all of them, and thus have a better chances of doing a deep problem solving, like anomaly detections across all your stacks, performing a massive correlations across your metrics to find something that you haven't really found before, or running on ad hoc queries to discover newer trends, and this performing discoveries, etc. So some of the things that we think ourselves as a differentiator against other competitors are these 6 different things. Because scalability is really important, and also especially with the cloud applications where high cardinality of the metrics data is a very norm. We actually have invested very, very much into making sure that our SaaS application can perform with a huge number of cardinalities and a huge number of metrics data that it is actually a top of our vendors in our market today. And this is one of our competing things that we always talk about, is how fast we consume data and make it available without you having to do it yourself. The next thing is that we really also understand that some of the tools and monitoring systems out there nowadays have certain period of rolling over the data. So for example, for the first 3 months, they will have the actual data that they receive, but after 3 months, because of performance issues or a lot of the storage requirements, they tend to roll up or aggregate those data into summarizations, like averages or min, max, or certain percentages, and only survive those data into the storage moving forward. It is actually useful to a certain extent, but if you are having to do with more analytics across the full year spectrum or a couple of years terms, then that can become problematic, because now you lose the resolution and granularity, and you cannot see the data you saw before. Wavefront, the really nice thing about the Wavefront is that we never roll up or lose any data. So all the data that you are sending to Wavefront are safely persisted in many duplicate copies, so that you don't lose them, but also do not lose any of the resolution of the data itself down to the very second level. So you can be safely assured that all your data that you're sending to Wavefront is going to be there for you whenever you need it. The other thing about the Wavefront is how easy and quick it is. A lot of the evaluations or proof of concepts we do amazes our customers, because they can start using Wavefront from day 0, and then quickly be able to collect all the integrations that they need using our integrations, very, very easy integration tiles, and then be able to create very, very compelling dashboards and visualizations right from the back. So the whole process is very easy, user-friendly, and also DevOps-friendly, because a lot of the features like query languages or alerting features are geared towards self-serviceability. We now understand that nowadays the DevOps teams have a challenge of making many things by themselves or doing many things by themselves. So we wanted to make sure that many of the features that we have are self-service, meaning it's quickly easy to catch up by the developers or ops team, and then be able to be part of their automation, part of their deployment, part of their integrations very quickly and very easily. Now, the third thing is the full stack correlation. We're showing one of the examples in our demonstration, but the whole idea is to ask smart questions of what sort of metrics are there that look a similar behavior, exhibit a similar pattern with other metrics happening on the other side of your stack. This is super useful for discovering new anomalies or new patterns, and it is something very advanced that we make it really easy for just anybody to just use it to perform many different correlations between matrices, but also between the systems as well. There are simply no limitations on how much you can correlate different metrics to. The next one is the best analytics answer smart questions. We have over 100 different analytical functions built into the query itself. So not only it aggregates and filters and the matrices, but it also performs many high-end analyticals like calculating variances or deriving a SQR or the standard deviations, and using that standard deviation to other queries or comparing different deltas for each other, and performing a lot of the interesting but yet very unique analytical by using coordinate images. So a lot of the things that we saw as a thing that the DevOps people want is they didn't really want it to be limited by just pressing knobs and turning dials on the UI. They wanted to perform their own investigations in much broader way or much in a dynamic way. So we actually incorporated that kind of a characteristic in our query. Lastly, the intelligent alerting. Many of the problems that we see in today's modern applications is that people are flooded with alerts. A lot of the alerts are just too sensitive. So they see hundreds and thousands of alerts. It is not really useful if you see that many alerts or events happening. Even though you have all the data, they're not really meaningful because it reduces the time to resolve those events properly. So intelligent alerting actually helps developers to raise just about the right alerts more accurately with more complete data across all the stack, so that they could not be fatigued by all those false negatives or false positives happening all the time. And that's some of the things that our customers really praise Wavefront for, because now they have a single place that they can just create the alerts and don't have to worry about all the other parts. So those are kind of the 6 main Wavefront differentiators, and these are some of the things that we talk actively to our prospects when they ask. So what's so special about the Wavefront? What does it do? You should definitely know about these 6 main features and start talking about them. This is just a quick comparison between many of the modern monitoring application stacks that we see out there. Because customers typically ask when we do a presentation of the Wavefront, so are you guys APM, or do you guys collect logs and things like that? So this may be a really nice way to kind of distinguish what we do against logs and APM. Wavefront is a metrics collection system, so its primary data is telemetry data, meaning they're very lightweight in general. They have a name, some sort of a measurements like numbers, and also the timestamp. So the telemetry data is focused on measuring something of something in a particular point of time, and we are doing it for various intervals, like every 10 seconds or every minutes. So that's pretty much what the metrics are. It is kind of a very similar to the in-flight dashboards of a flying airplane. The pilots are the ops team or the developers who are manning the airplane to a certain destination, and the airplane is an application. And usually when things are moving fast and things are getting continuously integrated and delivered and pushed, you tend to not to look at other things, but to keep maintaining a vital kind of a dashboard measurements, like the speed of the airplane or the altitude. altimeter of the airplane, the fuel levels and things like that. Those are the necessary things, but very important things to properly, navigate the airplane to the destination very safely. They're very real-time data, so a lot of the data are coming in very, near real-time fashion, and that's what the metrics are, and that's what Wavefront is trying to monitor. It's one pillar of the observability where the real-time and the pace of speed is very important. Compared to the metric system, the logs are less real-time, where all the events are mainly gathered. So it's not particularly the measurements of something, but it's just generally a description of certain events like system crashes or exceptions or error happening and things like that. And logs are really useful at recording all of them. However, they are not really useful to take a look at in real time because the events and logs are just so many, and it takes time to evaluate those or investigate those. So they are slow to retrieve, but have a lot of detail, and very useful to kind of investigate after the crash or after something goes wrong. You retrieve the black box and you take the flight recording, and then be able to analyze it. So it's not particularly for the real-time operations. The APM is everything in the kitchen sink, so it's kind of a schematic or the design of the aircraft itself and how everything is wired together. So it has the highest level of details, and it's very useful during a development process or testing processes where the code is continually being tested and being meticulously kind of scrutinized in order to remove the bugs and to cope with the error conditions. But they're also very expensive in terms of trying to run that in real time when the airplane is actually flying. And because of that cost, it typically inhibits a lot of the airflight companies to run these kind of a diagnosis and troubleshooting during the flight of the airplane. So just to give like a simple comparison of these three monitoring technologies in modern application observability, metrics are small and fast, very nimble, and also less expensive and more performant. It is really good for eyes and then able to detect a lot of the anomalies very quickly than other things. So it's good dashboards for the aircraft. Logs are large, slower, and expensive to store. And it has been the traditional ways of monitoring, applications, but it's generally being less preferred if you are going into more agile environments where the speed is the concern. APM traces are also large, intrusive. It's very detailed, but also slow and expensive. So many of the characteristics of the NPM, when we talk about the customers, is that they are mainly concerned with the cost of running the APM and be able to cope with the sizings of the APM solutions and also the storages. And the license itself is pretty expensive. So even though it's very powerful, it has a lot of the very, very attractive features to help the developers. The cost is something that of a concern, and thus many of the customers do not really run APM on the production, and thus cannot really monitor the same way that they would monitor the developments or the testing. And that's where the metrics actually are very valuable in running something in production. So we are in the metric space, and we have had a very successful track of helping many of the large enterprises, mostly in a SaaS application area, because the SaaS customers actually understand the SaaS. So since they're like customers like Intuit and Workday, they're heavily on SaaS. Their main business is providing these kind of services as a service. And because of that, when they are choosing how to monitor their applications, they don't necessarily want to develop any of the in-house monitoring tools. They have actually first started to develop their monitoring tools using open source, but then they quickly realized that they have outscaled those technologies. So instead of investing too much money, they actually prefer to work with SaaS solutions like Wavefront, because that solves all their problems, yet it is super easy to use. So a lot of the success customer stories actually come from the fact that they have been using open source or some monitoring tools, and over a period of time, as they become really successful and starts to grow the system, they outgrow their monitoring tools, and so they are hindered by this visibility challenges, observability challenges, and hence they consider using SaaS-based monitoring approaches, and a lot of times Wavefront, because we are very scalable and also provide a lot of high-end analytic capabilities, loved by our customers and praised by our customers. So we have a lot of use cases across all the industries, because monitoring is not just a problem with a couple of industries, it's a prevalent problems across all the industries. And as we are becoming part of the VMware, and more enterprise customers are also taking notice of SaaS monitoring cyber. Integrating the Wavefront is pretty easy. We have various ways to integrate the data. And we make sure that the data integration is not really hard, because that's where many of the productivity comes in. When you want to monitor something, you have to do it within a couple of hours or a couple of minutes even. If not, then you're in trouble. So we have an open source data collection agent called the Telegraph that we use very much on many of our integrations. We try not to use any vendor-specific integration agents, because we discovered that customers do not necessarily like vendor-specific agents, because it's too limited and also proprietary. It has a dependency on certain vendors, so thus they end up having like multiple agents running across of their system. It's a management problem. The Telegraph, on the other hand, is based on open source. It's been contributed by many different vendors. We are also being a part of it, and it has a lot of the input plugins and output plugins that makes it real easy to roll it out, deploy, and configure it. So we use that to collect or push the metrics into Wavefront through the Wavefront proxy, where it's kind of working as a gateway to collect all those individual metrics pieced together, flow control it, decrypt it, pre-process it, and send it into Wavefront in a very secure manner. We do have very good integration with the third-party time series database. So understand that many of the customers are probably using one of these. And if they are doing it, they don't really need to replace it or take it out. If they want to keep using it, which seems to be the pattern nowadays, where many different DevOps teams have their own preferable solutions. Some like Prometheus, some like to use Zabbix, or some use the OpenTSDB to store their metrics data. But our aim is not to replace them or not to disrupt them. Our aim is to collect and aggregate the metrics time series data and give a single view for the full stack of observability in a much easier fashion. So we also work closely with all those third-party time series tools to collect the metrics and send it up to Wavefront. There's also many of the instrumentation libraries written in many popular languages like Python, Golang, C#, Java, or JavaScript that you can instrument in your application code. So while you're developing, you can easily inject these kind of codes into your application so that they can emit business or custom metrics automatically to the Wavefront. We also extract logs from the log files, the metrics from the log files. There are part of the log files that has the metrics data, like counts and numbers and things like that. We use the FileB to periodically collect and parse the log files and send it over to Wavefront. We also have a native cloud services like AWS, GCP, Azure, or container orchestrations like Kubernetes, PCF, PKS, or the Dockers that can be deployed and also automatically collect the metrics when they're deployed and running as a part of the sidecar or nozzles or apps. We'll emit the metrics without too much of an effort from the users. So we do use many of the APIs that's available or many of the technologies to collect the metrics that's available. And with all that, all the matrices are eventually be stored and be ready for their visualization. So that's pretty much part of my the introduction of what the Wavefront are and what is its main features and how do we generally do the integrations and how we send the data to us. Wavefront is a SaaS-based solution, so it runs on cloud. Everything is provisioned on our end. And the areas that the users typically get involved in is when they try to integrate to their systems to the Wavefront. So my demo actually starts with the integration itself. So here are the integrations where the users can kind of go around collecting various tiles. And we have organized the tiles in such a way that it shows the cloud tiles as data stored tiles like Oracle databases, or MySQL databases are here. Some of the third-party monitoring tools that we hook ourselves up with them. Operating systems, application instrumentation libraries, DevOps tools, so we can monitor some of the DevOps tools, how they run. Also sending alerts and notification to some of the ends using webhooks in various formats, and also others. So have a couple of really nice integrations options presented as tiles. And in this example, I'm just gonna click the AWS tile and show how it is being integrated. So this is when you click the tile, you probably can, you pretty much can monitor the real-time ingestion matrices. So in this particular integrations, 1.5 kilo points per second, or this is the how many points are being ingested currently to the Wavefront, averaged into per second ratio. And these are one of the data CPU utilizations that we are looking at it. And when you're hovering your mouse over it, you see all the instances that the EC2 system is sending the Wavefront to. Okay. Okay. And these are some of the dashboards that the integration is actually using to visualize the data. So the EC2 metrics that you just saw when going into the dashboard pretty much look something like this, having a kind of an overview-ish single stats to various details like how each individual EC2 instances are, what their names are, their storages, their network activities, all being loaded in real time as you roll down your dashboards. So it's super fast and can cope with a lot of the instances, thousands of them, and show you a very, very, very fast and quick ways to set it up, and also start monitoring your environment in today's. Another example is this globe view of the EC2 instances. So this is actually our new UI that's coming up in a couple of months from now, where you have navigational capabilities to drill down into a particular region. Look at the overview of all the EC2 instances in really nice graphical, hit map kind of a way, so that you can kind of pinpoint the slowest running instances among your hundreds and thousands of nodes. And then just click it in order to get into or drill down into that particular instances and see all the metrics that's happening. So that from the global view, we are going to regional and also the instance view in matter of clicks. So this is, and these are all customizable, meaning that you can create your own links, navigation paths to create whatever makes sense to you. Another example is our performances. This is actually the chart that visualizes the year-long utilization of the CPU across all your clusters. So you see a lot of the lines with different colors. Some of them are, many of the CPUs here, and some of them are just sparse. But this yearly view actually has over close to 1 million points across the full year. And then Wavefront was able to query this and display this in a matter of seconds, and without any resolution loss or downsamples. We have a lot of the functions that I mentioned, a lot of the analytical functions that you can kind of perform very conveniently without you having to write the query itself. So this is using a query builder feature. So I'm going to just simply perform a average calculation of all the CPUs happening over a period of 1 year. And just like that, just like 1 second, the Wavefront was able to calculate all the average values of all the CPUs within this 1 year period, very fast, very quick, so that you can look at it. We can also provide other summarization method because we are not really sampling them in averages. For example, rather than looking at the averages, maybe we want to summarize this based on the maximum CPU surges, so that we can highlight whenever or whichever CPU actually performed the maximum within a year period. So when we run that, now we have a totally different view, but a very meaningful view, showing there are 2 points where the CPU was actually pretty high across all year. So this may be a problem, so we can actually zoom in. And as we zoom in, notice how the Wavefront never loses the full resolution of the data, very down to the minute level. And when we remove this summarization, we can now see the actual server that was caused this high CPU surges and the actual value of it within a matter of a couple of seconds. So just like that, from a yearly view to a very minute view, we can perform many of the different aggregations, many different summarizations to understand the data much more better. And that's because the Wavefront has a very highly scalable, but very powerful performance in regards to running codes. The second demo involves the correlation feature. It's kind of an advanced topic where you're asking the questions that is normally not found in many different tools. Let's say that you have been monitoring a transaction per second ratio of your application and be notified and alerted that the transaction per second rate is dropping. So this must be a sign of some trouble or some problems. You want to understand very quickly, without going through multiple tools or asking people, why this is happening and where this is happening. And if you have many meaningful metrics data in a single place and have a single query languages and visualizations to do that, it can be really effective in discovering those issues. Now I'm going to cut down the transaction per second down into many different dimensions, because all the metrics are having a multiple point tags or the tags, and based on those tags, we can perform aggregations and then derive a meaningful results. So this KPI dimension is actually doing a total or summarization of all the transactions per second. I can break this down by customer using the customer tag. So just like this, I can see that there are 5 customers who are sending their transactions or running the transactions, but all of them are suffering the same problem. So this is not the cause of the problem. I can change by the application server to see how each of the application servers are handling these transactions. And when I run the same query, just like that, very fast, the Wavefront actually discovers something new. In here, in fact, there was only one server that was behaving bad, aside from all the servers. That was actually pretty normal. So we can now see the new information that this single server out of this cluster was the actual cause of the transaction per second drop, the main KPI drop. Now we have an options to just restart the server or remove the server from the cluster, and that will pretty much recover our KPI back to normal. But we want to do further. We want to investigate more and know what is causing, what is behind this transactions drop down of this particular server. We are not going to move our focus into application server number 5. And on the right side are all the metrics that we are collecting from app server number 5, which had a problem. And obviously there are hundreds of matrices, and the data itself is pretty noisy. If you kind of overlay all them at the same, on the same chart, right? Because they range from the CPUs to network to the memories and whatnot, anything that you're collecting. So this is where the correlation capability actually comes to play, and it's very vital. We know that this particular transaction count that has dropped here all of a sudden is a symptom of something bad. So what we're going to do is we're going to ask Wavefront a question. Show me all the matrices, not everything, that is looking similar to this pattern, something dropping down, or something going on. So we are actually running the correlations to discover the matrices that we normally don't know, or we are hoping to find. And Wavefront is very useful in doing that. So we are running a correlation using this input. And then what Wavefront can do is it can remove all the noises and discover only the necessary needles in a haystack, which are these three main matrices that seem to have a similar pattern as the dropdown of the transaction. So this can be a clue. The first one is the free memory. So we discovered that the free memory was actually dropping down, much of the same rate. The second one is the error logs. So we can investigate the log of this particular server to see what kind of log messages are there. The third one is a garbage collection. So immediately with these three kind of clues, we can have a better understanding of the problem, that there is a memory issues with the application server, and then it seems to be causing the garbage collections to go up, which is actually stopping or slowing down the transaction handling. Thus, it's causing the transactions to go down. So now with this, we have a better idea of understanding the problem, and also be able to notify the development team to look up into their codes and try to find out whether there was a memory leak or related bugs that were causing the memories to drop down. It is very easy to share these kind of discoveries in Wavefront. All the charts and dashboards have a shortened URL capabilities where you click this. This will expose a generated shortened URL. And once you get this, copy into a clipboard, you can send it to your Slack channel or notify your DevOps engineers, and they can open up their browsers, paste these, and then be able to see the same screen that you are just working on. All of these dashboards are dynamic charts or live charts, so that they can still drill down deeper into it and take a look at much of a detail, discover new trends, perform different correlations, or maybe run different filterings, and then create the shortened URL and send it back. So this kind of promotes very good correlations between different teams to share your findings much more easily. So these are the demos that I prepared for this webinar for now, and it's actually top of the hour. So I'd like to just quickly close this demonstration presenting by giving a summary of Wavefront. Wavefront is a SaaS metrics monitoring, which obviously focuses on metrics collection and monitoring capabilities, but it can perform very high scalable manner with the high granularity data. It has a very advanced queries and alerting capabilities to make developers ask any question that they want to drive the insight and discover, help them to mitigate the mean times to resolution, but also at the same time reduce the alert fatigues so that they can work better. The Wavefront is also very useful for integrating many different and diverse stacks and services together, because it has a very easy integration mechanism to send the metrics data over. And with that combined forces, it's helping the developers now in today's world to cope with the challenges of the modern application development. That's it for now. I'd like to close this webinar and maybe have some Q&A session for the remainder of the time. So Caroline, if you could please maybe read out some questions, then I might be able to answer. Thank you.
Yep, so if you have any questions, put them into the chat box below and we will answer those. Only the panelists will be able to see the questions. So looking at first question, this is one we get a lot, is just how does pricing model work for Wavefront?
Okay, very good question. Our price model is one of our, I guess, unique competency compared to other vendors. We actually measure the rate of data ingestion as the basis of our pricing. So what we do is we have a really nice way to monitor all the number of the points that we receive over a period of time. What we do is we calculate the average points per second rate, meaning how many points in average are being submitted to Wavefront in every second. With that number, we take the hourly averages of the points per second, and then over a period of 1 month, we get the monthly averages of points per second. Among that, we calculate the 95 percentile of it, so we run P95 on that number. And then we simply multiply by our unit price based on the tiers. So our tiers start with the 1,000 points per second as a minimum, but as it goes up to the tiers, it gets more discounted base price. And that's generally how the pricing works. It's very, very, very easy. It doesn't really matter how many sources or how many metrics names that you have. We don't really calculate that. It doesn't really matter how much storage that we are doing for you. It doesn't really matter. All we care is about how many metrics you are sending to Wavefront in every second average, and that will be the basis for the price. Contact our AE folks to help you guys with the pricing estimates, because we also do a lot of the estimation activities.
All right, thanks, Howard. Looking through here, I don't really see any other questions. So guys are a quiet bunch, but with that, just want to put in a plug. We do have a free trial. So if you guys are interested in seeing this for yourself, you can go to wavefront.com /get started, or if you go to the homepage, there's there it is on the screen there.
Yep.
There's a big orange button that will say click on that to sign up, and so you can try it out yourself. We also have great resources on our blogs as well, so I'd encourage you to visit those. So with that, thank you so much, Howard, for the presentation and for doing the demo, and thank you everyone for joining, and we will send out this recording to you soon.
Thanks for having me.